other trigonometric graph, which is tangent, cotangent, secant, and cosecant, are illustrated here. The thing that you have to consider is the function periodicity. So they repeat themselves by pi here, right? It repeat themselves by every pi. Okay, they repeat themselves. This is also same pi. So here this also this yeah, they repeat themselves by pi. Okay, by pi. And then the function, it has some limits where it will not touch the 2 pi. It is going to infinity. Okay, this is also going to infinity. So there is a asymptotic line which limits the function. And then you have to recognize which one is odd. This is odd. Yeah, this is also odd, I think. Okay, this is even. Okay, this is odd. Right, if I'm not mistaken. And then you can also translate them to the right or to the left, right, by just changing the argument of the function. All right, next we go to the trigonometric identities. Okay, some there are many of them, but I just introduced here. So in the exam or even in real life, we don't really memorize them. We use a table. We have an appendix of a identity, so we use it as a reference to solve a problem. So the first one is a sum and difference of angles. So for example, we have a triangle here. They have a different angle, internal angle ABC. And this is the side. So side A is this is angle A, side C, this is angle C, this is this. Okay, so if you want to for example add A and B, so for example A and B, so you can separate them. For example cos A plus B, okay, this is equal to cos A cos B. So because this is a plus, so you have to use sine A sin B. So you have to take care of this, you see. So you have, if you have positives on the left side, you have to have a negative in the side, and the right side. And there is also product as sums. This is a product as sums, and this is difference. Double angles. So this is double angles. Cosine rule. So you can have c square, this is equal to a square plus b square minus 2ab cos theta. Okay. And also lastly, sine rule. This is a ratio between the angle sine A to its adjacent side. So this will be useful in calculation. So lastly, we go to harmonic functions. So harmonic function, what is it? A function having the form of a cos ku plus alpha is called a harmonic function or a sinusoid in the variable of u, where a, k, alpha are constant. Okay, so we will have more complicated function if they all represent the we can recognize them similar to this form, then those function perhaps is a harmonic function. So what is the characteristic of harmonic function? For example, you are given a harmonic function y as a function of time equal to a cos omega t plus psi, where omega equal to 2 pi. So if it is a harmonic function, so that if you shift it by negative to half pi, for example, okay, so if you shift because this is cos, you can change to sine. Okay, in the previous slides where if we translate it to the right, okay, this is to translate to the right. If we translate it to the right or to the left, so we can change either it is cos or sine. So this will change the function to sine, from cos to sine. All right. Okay, and then if we shift by 2 pi, or either to the right or to the left, the function will override on itself. That means they will meet again to itself, right? That means it is just equal to itself. Okay, if we shift it by 2 pi to the right or to the pi to the left, because it will see itself. Okay, this is what we call a periodicity. So the harmonic function, it has this property where it can change from cos to sine by additional of half pi, and it also periodic in the 2 pi phase shift. Alright, so this is actually the function of wave. Okay, so it has an amplitude where this amplitude is A from here to here, sorry. Okay, and then the period is from this peak to its peak here, and then it has a shift pi here. This is equal to phi over omega. So this is the shift of this equation. We come to the end, how to locate the coordinate of this tip of the blade after 30 seconds of movement. Alright, so we put 30 seconds here as a time, so we get a position in y axis it at 1.2. Okay, so we can have first the border of the motion is around this area, right? So this is the better one. Okay, 3 radius. Okay, and 1.2 is about here, I think. Okay, 1.2 is y. So the position of the tip either here or here, we do not know, but we know it at y axis it is located at that level, 1.2 above x-axis. So what we can do is that we can write the letter in mechanics, or this is a vector actually, or the distance between here and here. We can make a rectangle. Okay, rectangle, so that it's become easier to understand. Then we build the theorem Pythagoras of the triangle, so that we have this is 3, because we know this is 3 already from here. This is the amplitude or radius of the circle, include everything. Then we can get x equal to plus minus 2.8. Why plus minus? Because it is square root, so we do not know whether it is here 2.8 or here negative 2.8. So we do not know. But from the argument here, so we can check argument here. The argument it said is 24, so it is cos 64. So this is in radian. So 64 is equal to, so if you divide by 2 pi, okay. So if you divide 64 by by 2 pi, okay, sorry, by pi, so you get 20.27 pi, which is one full rotation is equal to 2 pi, right? Okay, you can divide 20.27 pi divided by 2 pi, you will get 10.19 full rotation. That means the blade rotate 10 times from x. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a little bit 0.19 rotation. Here is 0.25, here is 0.5, here is 0.75 rotation. So this is between actually in the first quadrant. So it is at the first quadrant. So you can sure that the location is here but not here. So that the coordinate of this tip is at t equal to 30 seconds is at 22.8, which is here around 2.8, and 1.2 in y direction. All right. Okay, so next we will go further about using this trigonometry. Okay, see you then. Bye.